Hi, my name is Hongjun. I'm a final year computer science major, and today I'll be doing a quick presentation of my Internet of Things IoT CZ4171 course project. So today I'll be taking you through the course project I've worked on for the past semester. So for the front end, we'll be using Google's framework for mobile devices, Google Flutter. And for the backend, we'll be using Flask, which utilizes Python, and Tensorflow, similarly Python as well for the image recognition. And the backend will then be hosted on a Google product known as Google App Engine. So as previously mentioned, the front-end layer, we are currently doing a mobile application, and for that we are using the Flutter framework developed by Google. So the Flutter framework uses a proprietary language known as Dart, which is simple and high performance. So one of the key reasons why people use Flutter nowadays is that it is able to compile into both iOS and Android versions of allowing cross-platform mobile development, which is suitable for smaller agile teams. So for the backend, we are utilizing two technologies, one of which is Google's App Engine, and the second is the framework that we're running it on, Flask. Flask utilizes Python, which allows us to develop API endpoints that supports methods such as get, post, and delete. So a little bit more about the GCP App Engine. It is a fully managed and serverless platform which allows us to abstract away the key intricacies such as provisioning of the hardware servers as well as some elastic scaling. So as mentioned, Flask utilizes Python to create a lot of these backend endpoints which we'll be going through in the later sections. So for the artificial intelligence layer, we have chosen to use the Tensorflow Keras API developed by Google. It's a free and open source software library which allows software engineers like ourselves to focus on the machine learning and AI components, abstracting away some of the intricacies of having to manage so much data. So we'll be utilizing a class of models from the Keras library known as mobile nets. So mobile nets are models which have been optimized for low latency by making it as lightweight as possible. So even having it being lightweight, it still provides us with a good level of accuracy. So now I'll be demoing the mobile application that I've developed. So I'll be going through the various marking criteria as stated out by the guidelines and doing a demo for each. So now I'll be demoing the first point, which is the collection of user inputs. So as previously mentioned, we have been utilizing Flutter and Dart to build up our mobile application. So we're actually using this software kit from Android Studio to emulate a Pixel 4 device, which is an Android phone. So now I'll be doing a quick demonstration of the collection of user inputs. So now moving on to the marking criteria 2. On local inference and displaying of these inference results, as previously mentioned, I've created a TensorFlow MobileNet v2, which will do a lot of this image classification. So just to point out, I've created two types of inference, two different versions. One is on device, which I'll be demonstrating now, and a second version which is on cloud, which is on the Google Cloud, which will be done in slide 13. Moving on. So as seen previously, the project has been running on an emulated IoT device. So we are currently using Android Studio emulator to host this device. So this emulator emulates the Pixel 2 phone, which is a 5-inch touchscreen phone by Google as well. So as previously mentioned, I've done a version of image recognition on device, and this is actually inference on the Google Cloud. Okay, so what we are utilizing for this is actually the App Engine framework, which is a product by Google, and then we are using the Flask API, Python API. So as you can see on the right, we are actually able to create various extensions which takes in different kinds of HTTP requests. In this case, we have chosen to use the post request, which allows us to accept an image from the mobile device, run it through our mobile net inference, then to return a JSON, which gives a class and confidence level prediction. So in order to communicate between the IoT device and the cloud, we have chosen to use the HTTP request framework. So in order to make an HTTP request, you first have to choose the kind of method you would like to use. So what we have chosen to do is to use the post method. And in the post method, we have defined the body to contain the image file that we are looking to make the inference on. So this will then be transported via HTTP to the GCP server, and after the inference on cloud, a JSON response will then be returned to us. So the JSON response consists of both the confidence as well as the class prediction. So we'll be using the TensorFlow Keras library, and of all the models available, we'll be using the MobileNet v2 for our classification. So we'll be training and fine-tuning this model on the Google Colab, which provides us with a free GPU instance. So now I'll be doing a quick demonstration of our app's ability to support multiple concurrent users. So as mentioned, we'll be using the Android Studio, and we'll be creating two different emulated devices. One of which is the Nexus 5X, and the second one would be the Pixel 2 device. So as you can see, these are the two devices. Now we'll be doing the model inference. So the first one shows a Labrador. And the second one is lion. So as you can see from the logs, you're actually able to see this in real time. So we have reached the end of our presentation, and I'd love to thank you for your kind attention throughout this process. So we have achieved 7 out of the 8 marking criteria. Of the 7, we have done pretty much everything. However, for the 8th, which is the online model updating, we were unable to do so simply because our GCP instance didn't have the requirements when it comes to the GPU. So we are unable to do any live model training. So instead, what I've included is a snapshot, a quick montage of the coding development process, as well as the setting up of the GCP instance. I hope you enjoy, and yeah, that's all. Thank you so much.